Um, First of all, we're part of Optimus engineering group, is part of the PD&MS group, and we do the consultancy services. We provide the expertise for the front-end concept and assessment in the feasibility process. And it's a group of engineers across all the different disciplines. And we also have our risk and decisions team that help us in the decision-making process. And Sarah is here to talk to you about that a little bit as well, a part of this project. And Emily Negron, and senior project engineer for Optimus, part of PD&MS group. I do the project manager role as well, and my background is process engineering. Some people say that I have moved to the dark side because I'm doing project management instead of staying with process, but actually I think it's a good combination to bring the technical into the project management side. It makes a huge difference when you have worked with projects, when you have an understanding of the scopes, when you have interact with another disciplines in the background. When you start to lead in them, you know what are the restraints and what are the problems, and that gives you a bonus when we're running the scopes. When you hear the commissioning, the first thing that you're going to think is you're going to associate the commissioning when the platform is unmanned and we are dismantling the topsides and subsea facilities. But actually, there is a long journey before we get to that point from late light operation until the platform is totally dismantled. And as you can see in the graph there, we're going to move in a different process, like when we're reaching the end of the platform, the late life, when we're doing the brownfield modifications to keep going. Then we're going to go to the as-life suspension. That is when we start the preparations for the process, onto the warm suspension. That is when we start to deventorize the platform. We start to remove all the hydrocarbons from the platform, and we start the preparations for the removals. What is coming after is more like the P&A campaign. That is the famous one. Everybody talk about that, the plug and abandonment campaign. And then we move into the dismantle and removal of the platform. So the flush and clean. The flush and clean is part of the warm suspension process. It's going to take all the de-inventorize, the blow down, and all the preparations from the flush of the systems. So this is just an example, a typical example of an offshore platform in the UK North Sea. And as you see, you cannot see only the platform itself. You have to see everything as a whole. You're going to have the platform, you're going to have the export facilities, the condensate and gas facilities, you're going to have the umbilicals, you're going to have the risers, and you're going to have the subsea flow lines for another wells that connect to that platform. So when you are planning this operation, you have to have an understanding in the way that you want to do the sequence of the flushing. You cannot look just the top size separates of the other items, because what you want to do is you want to maximize the recoveries of the hydrocarbon if there are any of the system. You want to ensure that when you clean the system and you positive isolate it, you don't want to bring another fluids of contaminations. You want to leave that apart, ready to be removed. And then you have everything ready to go. So you don't want to affect project and schedule either. It's a planning behind. My suggestion for this, when we're talking about planning for this time of the COM activities, you have to start to look at them 5-6 years prior to the operation, prior to the execution. And the reason why is like, it's a whole process. You still have to go through the engineering cycle. You still have to do an assessment. You have to do a conceptualization of the options that you want to take on board. And then you need to look how you're going to execute that. There is a FEED preparation and execution and vendor engagement still. So what we do when we're flush and cleaning is like, we're going to define the sequences for the flushing. We're going to define the drain, flush, purge, and venting. And we're going to define the systems. We're going to look at them as a whole, and then we're going to look at the top size, and we're going to see what systems we're going to do, which orders we're going to do. We're going to always leave at the end the utility systems that we're using for the flush. Generally, when we're flushing the top size with some exemptions, we're going to use the seawater, inhibited seawater. It's the typical fluid that we use. Of course, if we're talking about the diesel system, we cannot do that. And when we have the MEC system, we have to bring another fluids on board. What else we look for that? We need to identify the risks. When we are looking this, and Sarah is going to tell you more, we need to have an understanding of all the options. Which directions we're going to flush? Which routes are we going to take? Where are we going to take the fluids when we're doing the flush and cleaning process? You're going to look possibilities like a disposal well, for example. So you need to have an understanding of the availability of the disposal well. You need to have an understanding of the injectivity of that well and the chemical compatibility of that well. So as you can see, there are a lot of variables in place that we need to take on board. And also you need to have an understanding of the temporary equipment that you need to bring. And Paul is going to tell you a bit about that, like how we need to look the area where we're going to bring the equipment, which equipment I need to bring, and the brownfield modifications, if required, any scope of work to bring a temporary equipment on board. Do I need additional connections to bring that equipment, for example? That's one of them. The typical risk of this is like the understanding of when you are flushing the fluids through the export pipelines, you need to have an understanding of where you're going. Like if you're gonna do it for one of the typical gas plants facilities that are well known, you need to know what is permitted to do there. Like what kind of fluids I can bring to the facilities. There are any regulations? Do I need to bring then a vessel on board? I cannot go through that system because it's impossible. Is the kind of problems that typical are there. So as you can see, as a whole, it's a big operation that we need to look all the permutations. We need to have an understanding of all the possibilities to do it. And we're going to work alongside with the client in the requirements that the client have, where they want to go, and nail it down. And for that process, SERA is going to take on board the auctioneering, the risk assessment. We're going to establish the criteria that we require. And as you will see in the process, there are some key ones indicators like as an environmental and safety. As you know, right now we're reaching the NSTA regulations. They are in 2030. And a lot of the work that is happening in the background right now is to meet that deadlines. There are a lot of brownfield modifications in place to meet the flare regulations. So we need to understand also the synergies. We need to have a clarity, what are the other modifications that are gonna be in the place in the facilities to make sure that there are no issues in the drawings, in the documentation that we're using as built. That is key as well. And for us, for example, our experiences is to bring the right people. When you bring the people with the right expertise to these operations, it's a significant difference. We work with EDC specialists. For the one that I don't know about this, EDC is an engineering down and cleaning. And we bring the technical, but when we work with a specialist, they bring their operations, their knowledge, their understanding of the issues when we are running this, and sometimes give us very, very useful information on actually you cannot go in that way, or actually we have tried that technology, it's not the best one for that case. Another issue that is very common in the offshore platforms, as you know, is the sand. The vessels can have a big quantity of sand, and we can only flush with the typical fluids like seawater. We need to look for alternative technologies, and some of them, for example, is steam cleanings, and that brings the question like, do you want to reduce any of the equipment that you're gonna clean and you're gonna flush for another operation? Do you want to repurpose any of the vessels for another assets? And that's critical because when you're using a steam clean, for example, you can affect the integrity of the vessel. So you cannot use that vessel again for a pressure operation, for example. But if you are aiming just to clean and then removal of the topsides, a steam clean is amazing. Like just get rid of the sand and allow you to be ready just for the removal. Another key topic is the cleanliness criteria. When you are working with a client and our clients, every operator have a different cleanliness criteria that it needs to be met. When we are flushing, that's our target, and we need to ensure that we are meeting that cleanliness criteria. And that's gonna help us to define all the philosophies for the flushing and the sequences. Right, as I mentioned, risk is a key here, and decision is a key as well. So I'm just gonna pass to Sarah that is gonna give you an overview of the decision criteria for the risk.
Thank you, Emily. My name is Sarah Stalker. I am a mechanical engineering by background, operations and facilities, and worked offshore as an offshore support engineer for quite a number of years. But the sort of latter part of my career, I've been involved more in helping the technical discipline engineers that I work with in making decisions and incorporating risk into that, because as you all know, we work in a fairly risky business. So I head up a very nattily titled Decision and Risk Group. It does what it says on the tin. So my involvement here with Emily and the team was, as you can see behind me, and as Emily has described, an extremely complicated, complex project where there's lots of moving parts, lots of dynamic things and lots of choices. And you can see behind me here, some of the questions that our clients are asking are things like, which disposal route should I use? What flushing and cleaning fluids should I use? Which direction should we push the fluid down the pipeline? And when you start to sort of look at these variables, you can see that there's an incredibly huge number of permutations. So how can we help you make that decision and provide the sort of optimized solution here? And I don't know if you remember the diagram that Emily showed us there, but just for that, single sort of platform with a number of subsea there, if you think about how many lines and pipelines you've got. We've got condensate, we've got gas export, we've got varying numbers of umbilicals. And just looking at that diagram there's something like, I think we said about 25 different subsea nodes. And if you then layer on all of the possible decisions that you have to make, around the fluid and the routes, you have some 100 different permutations. So how can we help you decide which 2 or 3 of those you may want to take forward into engineering? If you then add on the topsides, where you might have 16 different nodes there, and you're looking at it slightly differently, you're looking at the condensate systems and potentially looking at the different types of equipment. Again, you could be adding on a number of 100 different options there. So, for a system like the one we just showed you, 250 different possible permutations is quite a daunting task. But we can help you with that. So part of that is in having a very structured decision process. Now it might look a little bit complicated there, but what it does provide is, I say, this very defined way of looking at it and simplifying some of these things here. One of the key things about this approach is that it's scalable. You don't have to go right the way through the process, which I'll talk a little bit about now. If you've done a good frame, that may be all you need to do to solve the problem. But for something like flush and clean, generally we need a more complex approach. One of the things that Emily mentioned, which is really key about having a good decision approach, is having a good relationship and frequent contact with the client. And you'll see on the diagram behind me, there are a number of circles that I've dotted in there which reflect the touch points you need to have with the client. With this type of project, it's not good enough just to get the information at the start of the project and then go away on your own and have a look. It's very important that we work alongside the operations team, the wells team, all the decommissioning engineers with the client. And a key part is making sure that you have that continued involvement and their continued input there. So when I look at this process here, the very first thing that we have to do is conduct what we call a robust frame. And what we mean by that is getting everybody together who is involved in the project in any way or manner. And sometimes this can feel like a bit overkill, when you're bringing a lot of people into the room for a day. But the importance of this is to identify the boundaries. Often the work is going on in conjunction with other decommissioning work. So it's really important to understand how those other activities touch upon each other and just to understand what's in and out of the scope. Often there's other activities from other stakeholders and other partners. So we need to understand, how that work impacts on what we do. And the other key thing that at this stage is around, and this really is important in terms of being able to hone down and get rid of options that aren't valid, is understanding what the key decision criteria are from the client and also from the stakeholders. It might seem quite obvious, but it's really important to have that view to understand, cost and schedule is always there, safety is always there, but there are lots of other nuances to that. And importantly, you have to understand that not all decision criteria are equal and you have to make trade-offs. So you have to understand what the client is prepared to give or take. A good example is that in a recent project that we worked on, we had all the standard decision criteria, cost, schedule, environmental. And everybody thinks that cost and schedule will be at the top of the list. But actually, when we looked at it and broke down the decision criteria, some of the key concerns were around things like external stakeholders and the impact. A lot of the fluids are not just on the platform, they have to go somewhere. Usually there's terminals involved. How do they feel about that? How does that impact it? There's also regulatory bodies that need. So, the conversation with the client is often, okay, cost is important, but are you prepared to spend a little bit more to keep your external stakeholders happy? So there's often lots of conversations around that, and that's really important to do at the front end. Once you've got those tied down, and this can be the most difficult bit that takes the longest, but once you understand your criteria and the options, the rest is I say easy, but it's not, but it's easier. So once you've actually identified your decision criteria and you know what the different options are, then it's working through those options and scoring them and understanding how they then rank against those different criteria. It's understanding the risks associated with them. And I'm like to say that, we managed to, in the particular project that we give an example here, get from 250 down to 16 very good options that we could then say to the client to take forward into detailed engineering. So I've told you how we managed to get to those options, and my colleague Paul is now going to describe some of the more technical details around, some of the aspects of the technical side of things that we're perhaps not always aware are important. Paul.
Just give you that. Hi, good morning. My name's Paul Dallas. I'm the head of electrical and instrumentation for Optimus, part of the PD&MS group. On the flush and clean projects, one of the two things that are normally not thought about very quickly are the use of temporary equipment. Where are we going to lay that equipment down? So do we need to do a structural assessment of the laydown areas? Are our cranes still capable of lifting the temporary equipment onto the platform? Over years, they get derated, and you end up getting issues where you need to break down the equipment to actually get it onto the platform itself. Following on from that, from what Emily has also said, is your main flushing medium is going to be seawater. Now, that will entail the use of the seawater lift pumps. These are normally driven off the H3 switchboards, which means you're going to need to use your turbines. Your turbines are no longer going to be running on gas because you've not got gas on the platform anymore, so you're into a dual fuel, so you're going to be using an oil or diesel-based fuel. The issue you've now got is that you've not got the efficiency to actually have enough load on those turbines to actually run them in an efficient manner before they actually either coke up or emit NOx gases that are beyond the emissions use. So what we offer is a full integrated power study during the flush and clean process, going from late life through to full decom, and looking at where we can put mitigations in and how we can actually bring on temporary generation at an efficient time in the process. But those are the main sort of points that normally get missed when we're talking about the flush and clean process, because we're normally talking all about the process part and the decision and risk, but then we forget where we're going to put the equipment, how we're going to power that equipment, and how we're going to do it in an efficient manner that we're not going to be breaking regulations on emissions. So that's my small piece of a major project.
But very valid.
So what is the wrap-up and the reflections of the studies that we have made in Flush and Clean? The first one, I will say, don't underestimate the work. People think that the biggie is, like the dismantling and the end and the P&A campaign, of course, but you need to work early stages. Like I say, prior to that, 5 years, it will be a good one to have an understanding of your technical constraints, because you will be surprised. You start to find many. You need to understand the gaps that you are having to be able to execute this scope. You need to understand what are, like the key problems, the key risks that you are having that don't allow it to perform that operations as we stand. And as I briefly told you, one of the good ones is where we're sending, where we are routing that fluids. So as you know, we are reaching a point that a lot of the platforms in the North Sea are going to be in the seas of production, the COP, in few years, 5, 6 years time. And the vendors are going to be really, really busy. So my advice is start to engage with the vendors at early stages as soon as you have a definition of the scope, because it's going to be lack of some of them. There's going to be issues with the temporary agreement to bring on board. So it needs to be an understanding of these kind of issues that it could be potentially impact your schedule as cost. That is no one you want to have in this type of operations. When we are reaching this point, you want to be as efficient as possible to unman the platform as quickly as you can. Every time that you bring a vendor on board, the operator have a cost to bring that vendor. The operator needs, permits, helicopter, everything to bring them on board, and is the POV an issue as well. So it's a whole point, it's a whole of issues. Ensure that you bring the right people at early stages. Ensure that you engage with the TAR team, for example, which is critical because they're constantly doing the de-inventorize and de-energize of the system when we are in a TAR. TAR is a shutdown for the ones that don't know the term. So that is critical as well. These people have a really good understanding of the systems. And when we are looking the sequences and the isolations, they're going to say, actually, you can run that longer than you are saying, and we can go through this entire system without isolating at this point. So these are the key info that we need to have, and bring the technical expertise when you can. Bring the disciplines as electrical and structural, like Paul say, early stages, because these could be the good ones to create problems in the definitions of the scope. Optimus not only do flush and clean, we are involved in the decom process and PD&MS as well as us as a group. We are involved in the entire decom process from the late light operations until the execution. So if you have any questions or you want to know more about it, we are more than happy to talk to you more about this.
I mean, a project like this, how many people typically be involved?
Well, it's depending how early is the stage of the project. If we are talking about, like a feasibility concept, you definitely need the project management team, you need the rescission and risk, the E&I and process as a starting point, and structural. So I will say 10, 12 people initially, and that's going to start to increase as you are moving forward in the project deliverable phases. But make sure you bring the right ones early stages is my advice.
In terms of the entire life cycle, like from start to finish, once you get people on the next stuff, how many people do you have?
I need to repeat your question because they're recording and they asked me. So he is asking us for the entire process, how many people in total we could have. I will say no more than 20, like in the total team, because you're always going to need a lead and someone to do, the work in a lower rate. You don't want a lead engineer to do all the work. You're always going to rely on the senior and younger engineers to do the part of the work that they are capable to do, of course, with the right knowledge and the right guidance of the people. So yeah, I will say like no more than 20 in general.
Yeah, I think you're wanting to know about the offshore part of it, how many people on board you're going to need. Well, a lot of this stuff is the way it's hooked up with the temporary equipment. It's run from a single control cubicle on the platform. So you're probably looking at no more than 3 or 4 people, actually, when you're looking at it, once it's all hooked up. And, we will provide monitoring of the instrument and alarms back to your control rooms as well. So it's basically, once it's all up and running, you're only talking about a few people at a time.
You're welcome. Any other questions? Okay, thank you for your time, guys.